This problem gives us two positive charges on the x-axis. To help us keep them separate, I'll draw this one in orange and the other one in green. They're located at plus and minus A. We're asked to find and plot the electric field on the x-axis. The electric field from each of these charges has a magnitude equal to kq over r squared, and because they're both positive, the electric field points radially away from each of them. The distance r between any point on the x-axis and the green charge, I'll call that r plus, is x minus a, and the distance r between any point in the orange charge, call that r minus, is x minus negative a, or x plus a. Now let me sketch the electric fields. Both charges are positive, so the orange electric field points everywhere away from it, and the green electric field points everywhere away from the green charge. The net electric field is then the sum of the field from the orange charge plus the field from the green charge. We can see from the figure that there are three regions to be considered. To the left of both charges, which I'll call region 1, we see that both electric fields point in the negative direction. So each has a magnitude of kq over r squared, and each has a direction of minus x hat. That gives us this expression, valid when x is less than negative a. In the middle region, call it region 2, between the two charges, notice that the orange electric field is in the positive direction, while the green electric field is in the negative direction. That gives us the signs shown here. And in region 3, to the right of both charges, both the orange and the green electric fields are directed in the positive x direction. So each of those fields is directed along positive x hat. So this is the expression for the electric field at all points on the x-axis. Now we need to plot this function. I'll draw the x-axis with the magnitude of the electric field and the 2 points where the charges are located, minus a and positive a. These vertical dashed lines will help guide our plot. Let's look at the top expression first, where x is less than negative a. As x approaches negative infinity, this expression approaches 0, and when x goes to minus a, this denominator goes to 0, so that term goes to infinity. The negative sign out front makes the curve look like this. And now for the middle expression in region 2. Let's notice first that when x equals 0, these two terms are equal and cancel, so there's no electric field where x equals 0. Notice that the first term blows up to positive infinity where x equals minus a, and the second term blows up to negative infinity where x equals positive a. If we draw a smooth curve between those 3 points, we get something that looks like this. And finally, let's look at region 3. Notice that when x approaches infinity, the electric field approaches 0, and when x approaches positive a, this denominator goes to 0, so the electric field blows up to positive infinity. If we sketch a smooth curve between those 2 points, we get something that looks like this. Taken all together, that gives us the plot of the electric field at all points on the x-axis.